Good morning, everyone. Welcome to our presentation on reliability strategies and failure codes in Maximo. We're currently using version 9.0, the Maximo Application Suite. Thank you for coming. I really appreciate it. We're going to go ahead and get started first on failure codes, and then we're going to take a little bit of a look at reliability strategies. It's a new application with Maximo and how you can use that to improve your failure codes and also to improve your reliability in Maximo. So to start off, my name is Megan Matthews. I'm the supervisor of the Maximo team, and I have a team behind me. You'll see a lot of them on this call. We all work on different pieces of Maximo, but we're pretty familiar with all of this, so you can ask any of the team any questions about this after our call on cmms@nace.com. But let's go ahead and get started. So the first question I always get asked about failure codes is, why should I use them, right? Failure codes are something that it's a little bit difficult to implement. It takes some time to manage, make sure that everything's done correctly. And it's one of those things that is really hard to kind of justify in our minds. So the big reasons why you want to use failure codes, it transforms your data. So Maximo is all about data. You're entering data in there every single day. By using failure codes, you can transform the work orders that are in there into insights that you can use to change things in your system. So because someone's gone in there, they've said what the failure code is, what the problem is, and why it happened, now we can look at that data and make decisions on how we're going to do our preventive maintenance, how we're going to increase our reliability. All of those things can be changed based off of the data that's entered into the system. So if the data is not entered, you're not going to be able to see those events to take actionable movement on your system. The second reason is to establish preventive maintenance. When you're using the failure codes, it's very easy to spot patterns and schedule fixes before the next breakdown. So if something's happening like a bearing failure and it happens on a certain frequency and it happens before your next preventive maintenance schedule, you can take a look at that and change your preventive maintenance schedule so that you can accommodate or get that fixed before it becomes a problem. Or you can create a preventive maintenance record for something that's regularly failing that maybe doesn't have a preventive maintenance record on it. The next thing is to improve reliability. This is allowed through that data that you put in because it lets you understand why this is happening. So maybe you see work orders constantly that's going through, for example, for a bearing failure. If you're putting in your failure codes, you can see why that bearing failure is happening, and then you can do something to prevent that from happening. So if it's happening because of something like corrosion, maybe we can do something in the system to reduce the corrosion in some way. Maybe we reduce the amount of liquid in the system, or we go in and put in a dehumidifier. Maybe there's something that we can do to prevent that from happening. And if you see this happening on a regular basis, it's easier for you to identify and resolve so that it doesn't happen again. Standardization seems like something that doesn't really matter. However, when you're trying to go through and look at data, look at things that are happening, unless it's standardized, it's really, really hard to go in and find the points that match or the points that need to be resolved. So by just looking at notes or by just looking at comments that people make, one person is going to call something by one name, the other person is going to call it by another name, and it's not going to be very easy for you to go in and catch those things that are the same or catch those similar situations. So if I go through and I review all my work orders every 6 months, if I don't have a common system that they're using to identify things, it's going to be a lot harder for me to identify trends. So using failure codes, it requires a standardization process. Everybody's using the same word leaking. We're not using dripping. We're not using water. We're not using leaks. We're all using the same failure code leak, and it allows you to more easily catch that by standardizing what they're entering. If we can take these failure codes and review them, it can result in reduced costs because we're catching those things before they're costing us a ton of money to fix. It can also be very helpful with compliance. So when we have to go in and do regulatory documentation or meet regulatory standards, ISO 4224, which is part of the regulatory compliance, it requires us to have failure documentation. So by utilizing failure codes, we can have that required failure documentation and comply easily with those standards. The last thing is to optimize your PMs. So not only can we establish PMs, but we can look at the PMs that we're doing and look at the frequency that we're doing it. So if we're never failing, maybe that frequency can be extended out a little bit. If we're failing regularly prior to, maybe we need to take that PM and have it occur more frequently. So it allows you to make your PMs more effective and manage your system a little bit better. So the next question that I always get from everyone when we're talking about failure codes is, how should I use them? Because yes, they're useful. Yes, they're difficult to convince my team to use. So how should I use failure codes to make it even effective in the system that I'm in? So I have a couple of recommendations there based on what we've done with other plants. The first recommendation I have is make it automatic as much as possible so people don't have to go in and figure out what they're going to put in. By putting that failure code, oops, sorry about that. By making that failure code a default on your asset or location, it will show up when you create a work order for that asset or location. The next thing that you can do is when you add a new asset or location, make that field required so that when I'm creating a new asset or I'm creating a new location, I don't forget to put that in. And that way, if it's required, it'll automatically pop up on any work orders related to that asset. And the same thing on a work order, you can require the entry of a failure code when it's in a certain status. So typically what we would say is when it's in waiting approved before it gets submitted for approve, we require that you have a failure code, which should automatically pop up, and that you put in the problem. Those two things should be easily identifiable when you're creating a work order. And then when you change it to completed status, that you have all of the rest of your failure entries in there, the causes and the remedies. By making it automatic that way, you don't have to go in and review, see that it's not there, and send it back to have them enter it in, which creates a much longer process for you to manage and also for the technicians to have to keep going back. In this way, if they try to change it, they're going to get an error saying they have to populate it. They can populate it right there while it's still fresh in their brain and get it off to you. So that's going to be the best way to get it implemented. The other thing is review your entries regularly. If you have a failure code system that gets created when you start your Maximo system or whatever system, and you don't look at it regularly to make sure that it's accurate, it's going to get stale. So one of the things that we often do is we'll give technicians the opportunity to either request failure codes through the work order application. They can click a button that says, hey, I need a new failure code, and it can send a notification to somebody to create those failure codes, or to go in and manually enter their own failure codes in the system, depending on the size of your staff. By allowing that system to grow over time where it's needed, you're going to have a more active system of failure codes that's going to be more useful for you, and you're going to kind of grow that failure code system as you operate in Maximo. The next thing is review those entries on work order close. So a lot of times what happens is when people are trying to do something and they're required to do it and they don't want to do it, they're just going to put garbage in just to get it in the system and be done. And if we never review it, we're not going to see that garbage. So even if you only review, a smattering of them when you close them, you should be reviewing at least a few of them on a regular basis to make sure those are accurate. You should also establish a procedure for technicians. So when they go to something and there's a failure, you can take that failure code and look it up in the Maximo system and see if there's existing work orders that have the same problem, and then see what they did to fix that problem so that you can do that for yours. What that does is it reminds technicians that, hey, this is a useful thing. Other people can use it. I use it in my work. It's something that is worth taking the extra time to go in and put the data in because it's something that I will find useful. So making that a standard practice makes that data more live and more feasible for people to go in and do what they're supposed to do. And then the last one is make a routine to figure out if we need new PM. So if you have that failure data every 6 months, every 12 months, run a report, see what's happening, decide what you want to do as an action based on that data. If you never review the data, or if you only review it once every year, once every 3 years, it's going to be overwhelming and you're not going to get it done. So if you make that a more frequent time frame that you look at those and review those and make the changes based off of the reviews, it's going to be easier for you to keep up with it and for it to actually cause changes in your system. So the last question is, how do I implement them, right? What failure codes do we need? How do we set up problems? Is there something out there that I can just use by default? And the first thing you want to do is look and see, are there any existing failure codes in your system? A lot of times we'll put those in implementation and they may or may not ever be used because nobody ever looks to see if they're there. So review your system, see if there's already codes in there. The next thing, if you're building your own list, there are a bunch of ISO standards that have failure codes you can grab and utilize. We use 14224 for our standard list of oil and gas codes. It has a general list for you. There's 55000. It tells you how to use failure data in your system, so you can take that and figure out, what do I do with this failure data now? There's 4406 for advice on how to set up failure codes as far as cleanliness. 7000 talks about failure codes for malfunctions. So there's a lot of ISO standards out there that you can take a look. You can Google it. I'm sure Copilot or whatever will give you some good information on what you can put together for a failure code list. So you can search what's out there. There's also a new tool in Maximo that we'll go over called reliability strategies. And what that is, it's a group of data that we can use to build failure code lists. So as soon as we look at the failure codes, we'll look at the reliability strategies in Maximo and see if it's something that's useful for you. So what I want to do next is I want to kind of give you a view of failure codes. And I wrote it out here for people who aren't on the call. But what I'm going to do is I'm going to share my screen and show you what this looks like in real life. So the example that I'm showing you is an example of failure codes that are used across the board on our sites. We build out a failure list that can be used in general for our sites. So the way that you get here in Maximo is we go to Assets, and we're going to go to Failure Codes. So it's inside the Asset application. Failure codes is something that if you want to edit those, it's required that you be part of the Assets group as part of your list of applications. So when you look at the conveyor, I'm looking at conveyor, sorry, the failure codes that we currently have, you'll see a lot of these may or may not apply to your plant. And that's the problem with a generalized list of failure codes, right? There's going to be stuff in there that you'll never use, and there's going to be stuff that you want to use that's not going to be in there. And that's why you want to make it dynamic. But you can see we have pumps, packaging line, boiler failures, conveyor failures, spray equipment, hardware failures. So you can put in as many things as you want in here. I'm going to start with pumps because that's a general one that most people use. And you can see the class here is pumps. So the class is generally the equipment type. It could be pumps, it could be motors, it could be conveyor belts, it could be any kind of type that gets applied to an asset or a location. So once we have that class or that type, then we're going to see the next one is going to be problems. And the problems should be something that's easy to see when you go to create the work order. So I'm creating a work order on a pump. Why am I creating the work order on the pump? Because something failed. So that's my list of problems. It's either leaking, it's stopped, there's low pressure volume or low volume, low pressure. These are things that could be causes of failures. And again, you can build this as you go or delete things that you aren't using. Now for each one of these problems, these first two levels are going to be put on generally when we create the work order. For each one of these problems, I can create a cause and a remedy. So if it's leaking, there could be a number of reasons why it's leaking. Could be leaking because of the seal, because the shaft is scored, could be the housing is leaking, or there's a fitting that's leaking. And again, you could have more of these if you want. The next step is to say, if the seal is leaking, what can I do to fix it? What are my remedies? And then here we have adjust the seal or replace the seal. If you look at shaft, they have replaced the shaft. If you look at the housing, your options are going to be replace the housing, replace the gasket, tighten the bolts. So you're going to have a remedies or a series of remedies for each one of these causes. And this list can get very large very quickly. And that's part of the reason why it's easier to manage this over time than just to be a once and done and try and get everything in here all at once. So this is kind of just an example of what you're going to see. Again, as you build this out, you're going to add or remove, but that's generally what you're going to see for failure codes. So now that we've kind of talked about failure codes, I'm going to take a look at the work order application, and I'm going to show you where this gets applied. So when I create a new failure code or a new work order, you're going to notice in here there's a failure class and a problem code. So my failure class should come over from my asset. If it doesn't, I can pick it in here. So let's say it's a burner failure. And then the next thing I'm going to do is come down into problem code and pick Y. Maybe the flame has failed. So here's my class and my problem code. That's all I have to put in when I create the work order, and that should be good. Now, once the work order has been created and we've done the work, now we should be able to say what exactly went wrong and what we did to fix it. So part of closing out a work order is putting in the log and also putting in the failure reporting. So you can see here on failure reporting, it put in my class, it put in my problem. I can put remarks in here for things I want, but then I can select my causes. So my cause would be the sensor, the flame sensor was out of position. And then I can pick from here what my remedy was. Once I've selected that, I'm going to save this. I'm done. I can complete the work order and I'm done. So it should be fairly quick and easy for them to enter it once that failure list is built. What the issue typically is building that failure list. So often what we'll do is this remark section is where they're allowed to request things like an additional failure code or additional remedies or whatever. And they'll put a remark in here about the things that they want. And when they hit save, if they've put in a remark, we'll send an email notification to whoever's managing that failure code system and say, work order, blah, 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 says they would like a failure code of this. And that person who gets that email that can then go in and update the failure list to add that cause, add that remedy, whatever it is that needs to be added to get the system working the way that you want it to be working. Adding this email is a configuration in Maximo. So if you're on like a support plan for us, that would be something we would do for you as part of a support plan, or you would need to reach out and have somebody develop that or build that for you outside. Or if you have someone who can do it in-house, they can set up that process for you, but it's basically setting up a notification. So now that we've kind of looked over at these, I'm going to show you what IBM has put together, to help us build out these remedies and failures. And so I'm going to open the PowerPoint back up, and I'm going to show you a little bit about I'm going to show you a little bit about what Maximo's done with failure codes and all of that stuff. So I'm going to switch over to the PowerPoint here and go to the next slide where we're going to talk a little bit about what the program is that Maximo have. So Maximo purchased a program called the Asset Strategy Library, and they are offering this now as part of part of Maximo Application Suite. So if you get MAS, you get the application that includes the Asset Strategy Library. It's included at no cost. It's not really editable, so you can get to it. It's not going to charge you extra as a licensing cost if you have access to it, but it allows you to look at a bunch of data that's in there. So you can see in here, IBM has the data that they received is 25 years worth of collected data from 32,000 years of industry experience. It has a bunch of failure mechanisms. It has a bunch of preventive maintenance tasks that it recommends. It's got 800 plus equipment types covered. And you can see the reductions in maintenance. But this basically tells you what this is. So I'll let you guys review this if you want to. But basically, to go over how is it useful, what it does is it allows you, first of all, to define your failure modes that you want in your system. Secondly, to review your PM plan and maybe improve on the existing plans that you have, or you could be creating new PMs based on the PM recommendations that they have. And those PM recommendations have operating context, so you can say how critical it is and those sorts of things. So that's essentially what it's useful for. It's also used in some of the MAS applications that come with it. Maximo Health and Predict use the failure codes. So the next slides are kind of a review of what it looks like. But what I'm going to do is I'm going to switch us back over to Maximo, and I'm going to show you what it looks like in real life. So now you should be seeing my screen. And this application is also in the assets application, and it's called Reliability Strategies. It'll be at the very bottom of your list here. Sticker. Okay, so reliability strategies takes a second to load here. It is something that needs to be enabled in your system. It's not something that automatically comes through. So you may need to ask us to enable this, but you can see here, if it loads. Hey, Punk. Sorry, I have a puppy here and she's trying to chew things she shouldn't be chewing. Okay, I'm going to try and go back to this, because it was working this morning. And I think I just got timed out. So let me do this. Give me just one sec here. I have slides that this doesn't work, but I'd like to show you if I can. All right, so I'm going to go here to assets, and it's not going to show this one, of course. And that's where we just need to enable it. give it one more try here. Haha, here it goes. Okay, so this is called Reliability Strategies. It is a library of reliability strategies in here. And you can see if you go to settings, I can set up priority categories or risks based on different ranges or different types of actions that can happen. So I'm not doing that right now. And you can also add your own custom strategies in here. If you have something you need to load or you need to create, you can do that in here. But what comes out of the box, you can go in here and you can select an asset. This is a list of assets that they have. So you can see there's a long list. I'm just going to select valve from this list. So once I've selected valve, it's going to get me to the next section where I can select a type. So the valve could be an actuator, a check valve, hydraulic valve. So we'll put a check valve on here. And once I've selected that asset type, I now have over here a configuration that I can use. So it could have been a swing, tilting disc, inline. So I'm just going to put an inline check valve. And once I select that configuration, I click Get Strategy here, and now it's going to show me a summary of the data in here. So it has 21 failure modes for this type of asset and 6 mitigation activities. If I view failure codes here, I can see the different codes. So it could be a body, and the failure mechanisms here are corrosion, erosion, leakage. So body would be, it would be valve body would be the failure code, basically. The mechanisms or would be corrosion, erosion, and then once we do that, you can see the next step is fluid quality. And once we click on fluid quality, then we can see down here what different activity we can do. Diagnostics, internal inspection, radiography. So these are things that we can do to mitigate this problem. And then if you click on this particular thing, so if we want to do non-intrusive diagnostics, this is something that we should be doing every 3 years as a PM. You should take 6 labor hours to do it. And these are the details of what the job plan should look like. And then underneath that, you can see the different failure modes that are in here and the effectiveness of this activity on those different failure modes. So if we have this coming in often, this is something we should do. We should create this preventive maintenance record for every 3 years, and that should address the issues that we're having. So that's essentially what this is. Now, you can see based on the different things that we pick. So if we picked this one here, and this happened after corrosion during layup, now we can see there are more than one things that could cause, and that's going to give us 2 different activities. So this one here has 3 things you can try, and this shows what the typical effectiveness is. And this one has 3 things that you can try again. So as you go through each, you can build out those preventive maintenance records that you need. The other things that you can see here is this context. So if this is critical, you can set it as critical. If it's not critical, this is a minor issue. When this check valve goes down, we put it to minor. And if it's high cycle or low cycle, you can set those differently here. What's going to happen when you change those here is it's going to change the frequency that it's requesting. So ARs as requested, and then it's also going to change some of the recommendations based off of these contexts that you put in. So it's up to you to go in and put whether or not it's critical. So you'll see I click criticality here, critical, and it says I need to do this every 6 years, but this is minor. It changed this to do it as requested. So this allows you to go through and review those things that it's recommending that you do for this particular asset based off those failures, and then also a list of things that you can do to build your failure modes here. This, if you don't have it and you want it, feel free to send us an email, cmms@nace.com, and we can add this to your list so that you can go in and use it as needed. And then once you have it in there, feel free to request some training from us and we'll go in and show you how this works so you can use it at your plant. So that being said, we're at our 30-minute point, which was kind of where we wanted to be. I am going to go ahead and close out this call. And I definitely want you guys to join us for our next one. And I don't know how to get this back up on the screen, but our next Lunch and Learn is on Wednesday, January 14th. We're going to talk about ad hoc reporting and query-based reporting. Victoria Foley is going to present for us. Tori, as you guys know her. And then we will put these slides out on the Maximo site or on the Maximo YouTube site, so you can go in and review these if you want. All right. Well, thank you all for joining us. I appreciate it. And I hope to see you on our next Lunch and Learn.
Thanks, Megan.
Great job.